Hello, I'm Shelley Stahl with the American Geophysical Union, and I'd like to welcome you to Module 4, where we're going to be talking about developing a project preservation process. This is part of the 4 modules of helping those folks who are working with the Belmont Forum and the Data and Digital Output Management Plan. And this is what it means to think towards preservation of those digital objects and digital outputs. So hopefully you've had a chance to meet Allison. She has conducted modules 2 and 3, and I'm happy to finalize the whole learning experience with module 4. So I live in Maryland near the Potomac River, and this is where the Piscataway peoples are from, and their name means where the river bends. And I want to acknowledge that those traditional owners and custodians of this land and the land where you all are, of the land and the sea, all the nations, that we honor their profound connections to this land, the water, the biodiversity, and the culture, and pay our respects to their elders present and emerging. So you've seen this graphic now ever since Module 1, and I'm just going to take a little bit of time because we are coming into the idea of preservation, and this happens when you've made progress, and preservation can happen during your project as well as at the very end. And I just want to get some vocabulary really clear. So in Module 1, we talked about using the word digital object instead of digital output, because an object is something that may or may not actually be preserved as an output. It may be something interim in your project, and it helps to include all of the different areas, the different types of digital objects that you're going to be working with in your research. So a data and digital output management plan. So we've changed those words, right? We talk about data and digital object management workbook, right? Remember that. There are different versions, a lighter weight one for pre-proposal, and then there's more content added for a full proposal, and then more specific implementation when you get an award from the Belmont Forum. And congratulations if you have done so. That's fantastic. So output are things other people see outside your team. So this could be a conference presentation, or it could be some sort of code and data associated with a peer-reviewed publication, both peer-reviewed or not, or as it says here, refereed or not. There are multiple ways of providing output. Preprints, for instance, is one that's not refereed. And then you'll also have reports that go to the Belmont Forum where you have to prepare and think about everything you've created, all those objects and or outputs. So the first year, and most Belmont Forum grants have more than 1 year. So the first year you have a report, and you need to have everything prepared and preserved that go into that, that you're reporting, documenting, having completed for the project. Depending on what kind of project is, you might not have peer-reviewed publications for several years, or you may have them in the first year. It just depends on what your goals are. And then within the data and digital output management plan, you're tracking all of these things, and you're keeping those records, and you've documented exactly what the resources are, the tools and locations that everyone's going to go for their code, their data, their software, and such. So with that as a premise, let us move onward. So here, this is Module 4, and in Module 2 and 3, I'm just going to read this a little bit to you. We've chosen a repository. Likely it'll be a different repository for your data as your code, but it might be the same. The data has been prepared according to FAIR standards, and we will talk a little bit more about those here in Module 4. And you have tested for reproducibility and machine discoverability using those FAIR principles. Very good metadata. You're also accounting for sharing agreements and any of the challenges that you might have with either culturally or national laws about what the sensitivities are for what those sharing agreements are. And now it's time to start thinking about those next steps and what it means to put all of that into place. So here we have the life cycle for a project, and we have it in the optic of data and the digital objects. So in order to do your research, you're going to have to gather some data, because what is research without data? So you're either creating it, acquiring it, identifying it from somebody else, as in a synthesis project. You're going to aggregate it, collate it, harmonize it, and you're likely storing it in a temporary location that is accessible to your entire team. And you made that decision and documented it so your entire team knows where the common locations are. If you've got very large data, that might be in a different place than some of your other project materials. So that is a very real situation. It's possible you might need some cloud storage. So when you're doing your analysis, if you have very large data, you might be having the code and software running in the same location as your data to optimize that platform, or not. Or you're actually working on your laptop, and that's fine, because that's just, you don't need something that has larger horsepower, and that's okay too. You're off in the right here, where we're talking about team communication within this circle. You have common ways to communicate. Your team has all of its persistent identifiers. You know exactly what the ORCID IDs are for each member, and you know exactly what the RORs are, which is a persistent identifier for each organization and affiliation. So you're coming into some research findings, you're presenting in conferences, and you're getting ready to write your first peer-reviewed publication. You might be doing some training or workshops around this, depending on what kind of thing you're doing. And now it's time to preserve everything and get it ready for publication. You might have preserved the entire project. We recommend that you do yearly at the time that your project you're reporting to the Belmont Forum. And so you want to make sure everything is being captured and backed up, because everything you're doing is a real unique thing. You don't have time to redo it. You don't have funding to redo it. It is a true asset to your research. All right, let's keep going. So in this module, we're going to hit 4 topics. We're going to go back and look a little bit at FAIR, and we're going to map those into the Belmont Open Data Policy and Principles, because remember, the Belmont Forum is who's funding us, and we must talk about these things, and we must make sure that you all know what those mappings are. We're going to talk about those strategies for preserving your research project. It's not just the end of the project. It's not just at the time of publication. You actually want to protect your content that you've created and worked so hard for on purpose, in order to ensure that it's protected, it's easy for everybody to access, and it's well documented, and all of those three things go together. We're going to talk about data security, that you understand what the terms and conditions are for each of the platforms that you're using, and what the protections are. So let's say you use GitHub as a software development platform. Do you know what those terms and conditions are? Do you know what they're liable for should there be some sort of loss on their side? These are things we pay attention to. What are the costs of data management? What does it mean to actually build that into your budget? Do you need to think about that too much? Yes, you do. So let's bring that to your attention. And then when your project comes to an end, congratulations, you've published everything, you're amazing, and you're being recognized for it. It's time for you to back everything up and close out your project and make sure what matters is preserved and available to others. And also remember, sometimes the papers don't get written until after the funding runs out. Are you sure you're going to have access to everything? And let's make sure you do. All right, here we go. We're going to get started. So let's talk a little bit about FAIR and mapping that into the Belmont Open Data Policies and Principles. So we remember FAIR, findable, accessible, interoperable, and reusable. And one way to think about it is in conjunction with the concept of being open, that you want things that you want the work that you're doing within this project to be as open as possible and as closed as necessary. Now, FAIR and open are 2 different things. We put them on this same slide. We could have an entire presentation on why I said they were 2 different things. But for your purposes, you want things to, no matter how open they are, if they need to be protected, they should still be fair. They should still be well documented. So what it means, in the very basic terms, when we have persistent identifiers and good discoverability metadata, those data sets and software are easy to find. And here, FAIR can apply to other types of digital objects as well, despite the fact that it started out for data. And when we're preserving data in a repository that's a community accepted repository, they're following guidelines that allow that data or other digital object to be discoverable and actually accessible so that you can actually gain access, so that your tools can actually work with these digital objects. You can copy them down, for instance, would be one example. Further, when that data and or other digital object is well documented, anyone can read the information about it, the metadata about it, the documentation about it. These all mean the same thing. And the data is formatted in a way that's interoperable. And when you build all of that together, findable, accessible, interoperable, and you add in the concept of reusability, such that you're licensing that digital object, that data, in a way that you are affirming that it's okay for that that item to be used by you for another reason, by somebody for another reason, then you've actually reached you've completed the FAIR acronym, and you've achieved nirvana. There you are. You've achieved FAIR nirvana. So it's hard to actually do this. It's hard to actually get as optimized as possible. So what we do is the best that we can. And I want to remind you that when you do use somebody else's digital object, that's part of the scientific record, and you do need to give attribution and credit to that person. So just by licensing something to be usable by others means that you're also agreeing to give that person attribution, to give that team attribution, and that acknowledge the fact that you've used their digital object when you cite it in your paper or other scholarly document. So both of the sides of that are important for attribution. All right, let's keep going forward. So the Belmont Forum Open Data Policy and Principles, which were published now a few years ago, they came right before the FAIR principles were published, or right at when they were published. They aligned really well. Discoverable through catalogs. Your data and digital objects will be discoverable through catalogs and search engines. So that looks like findable quite a lot, right? Accessible as open data by default and made available with minimal time delay. So this is accessibility, just like A. Understandable in a way that allows researchers, and including those outside the discipline of origin, to use them. So that's well documented with metadata. And then manageable and protected from loss for future use and sustainable, trustworthy repositories. So that's not quite the license, but it does include the reuse, which has to be licensed, and the fact that you've chosen a preservation repository that helps you to document and support your data over time. So that bottom left QR code are the trust principles, which are a definition or a framework for discipline-specific repositories and other data repositories. So it's very interesting for you to take a look at. That's the acronym TRUST comes from. And then on the right here, we talk about how your team can respond to each of these. Controlled vocabulary helps with discoverability. Being as open as possible and as closed as necessary helps to identify which data, let's say it's data about people, and that needs to be protected. And we want to make sure that we're promptly publishing these digital objects in an open way, or as open as possible, meaning that when most publishers require for peer review publication, the data is available at the time of acceptance. That seems to be the expectation, and is a good rule of thumb that the data that supports the findings of your research needs to be transparent, have integrity, and available for others to take a look at. That's a good rule of thumb for when your data needs to be made open and available. So making sure that you have comprehensive, precise descriptions. We're really talking about metadata schemas and controlled vocabulary and following standards. Your communities will have some information about this, and this is continuing to evolve and improve. And ensuring that you choose a trusted repository for your digital outputs And there's yet another QR code here. Now, this one's kind of humorous because this QR code is for generalist repositories. Generalist repositories don't actually help you with your metadata. So if you cannot find a discipline-specific repository, then this list will be helpful to you. So let's move on. We're going to head into strategies for preserving your research project. All right, I'm very excited. I really believe that if we do a good job preserving our research, we're doing ourselves, our future selves, a huge favor by getting it all organized and making sure that it's understandable by yourself and your team. It will be understandable to others. So if you think about it from that point of view, it's really something you're doing to benefit yourself, your teammates, and then the broader community who's interested in your work. So let me give you an organizational picture, and you might just want to screenshot this and keep it available to you as you're listening to the rest of this video and thinking about your project. So when we talk about digital object registries, which Allison talked about in the previous modules, and we talk about the project in its entirety, I actually want you to think about it grouped like this. So here's your research project, and we all have a unique approach. Like all research is building on something else. So we're constantly evolving, constantly doing something a little bit more unique. So I'm not saying that there's only one way to do this. I'm just giving you a general idea here. So on the left, we have project files, and think about that as like, this is the work of research. You've taken a look at the landscape, you've collected a whole bunch of references, you've got those documented, you're making those available to your team. You have working documents. You've got, what is the methodology we're going to use? Yeah, I know it was in the proposal, but what have we learned since then? How are we evolving? What are the interim findings? Are you making progress? Are we working through all of the challenges? Are we finding the resources we were looking for? Sometimes yes, sometimes no, and we adjust. What are those resources? What data do we have? Is the data good enough? Are we communicating when we're finding some deficiencies with whatever data we're looking at? And on and on. The code, and then we've interim products. We want to tell people about our work and gain potentially new collaborators. We do that through conferences. We have interim products. We have a poster perhaps. Your postdoc has a poster. All of these things need to be preserved and protected, because if you lost all of this, like the hard drive disappears, this is not okay. This is not okay. You need to actually make sure these things are protected so that you don't have something catastrophic and you can continue to work forward and you don't have to deal with a very high risk project where your files could be lost. You don't want that. So on the right-hand side, this is a very administrative topic that everyone needs to have to support. So you might have someone assigned to do this, but your principal investigators and everybody leading teams needs to make sure that all of these activities are being done. So a digital object registry is a place where you're tracking each of the objects and outcomes that are meaningful for your project, all right? Such that you always want to know where they are, and these are things where you want to, in your yearly report, you want to talk about them. You want to make sure they're hailed for the wonderful thing that you've done. They may be go to your tenure review process. Maybe they're part of your performance review for the last 6 months or so. Or this is how you're going to gain access into a new fellowship or some other program for one of your students or technicians or postdocs or you name it, okay? This is important. So the tracking sheets that we've talked about in the previous modules, these track both the objects we're working on and eventually the outcomes being preserved with a digital object identifier, persistent identifier. And we break them down when we're providing examples. We break them down by peer-reviewed publication, non-peer-reviewed publication, like a poster, data, and software. So we have them in those 4 categories. You could do it differently. Doesn't matter. You could have 4 tabs. Don't care. Just make sure you're thinking about each of those different types so that you're tracking them and people expect them to be tracked. And you have a habit of making sure, what do you have? Where is it? Another way for these tracking sheets to be used. So think Belmont Forum grant crosses countries, crosses time zones. And what if you have teams across the world working on hunting down data sets associated with migration or atmospheric conditions? What happens if your teams are finding the same data sets and doing analysis to determine, is this useful or not? You don't want to duplicate effort. One of these tracking sheets could be useful to help one team inform another if they've already seen it and the kinds of value or challenges that data set has, so that you don't waste time and you don't go back and repeat yourself. So this is another way you can use it. Okay. So then teams are big. Teams are big and there's people coming and going. Let's say the PIs don't change, right? Because that's the intention. We want to keep our PIs usually. But you're going to have a churn, especially over multiple years, and you want to track who's coming, who's going, who's been trained, who's signed the code of conduct. You want to make sure you have the ORCID for everyone, because every time something is to be published, you've got to give attribution. You need to make sure you have social media for everyone. That's one of the ways to promote the things that you're doing. You want to push out against social media and have them do retweets and likes and all of the things for altmetrics. All right, so that's important. Next one, annual and final reports. This is not only for the Belmont Forum, but it's for each country. A good way to approach this is the team gets the Belmont Forum annual report ready to go, and it's open and available to everyone to take the sections that they need in order to fill out their national reports. This is going to be frustrating because national reports have a separate format than the Belmont Forum. So you'll have some things ready to go and some things that still are needed. And it might be helpful for you to track what those additional items others need so that you can have them ready to go, even if the Belmont Forum doesn't need it. I can assure you, this is the most laborious task. And if you can get everybody organized to help support it and make the person who actually has to submit it their job easier, this will just be much better for the quality of work that's being reported and what's going across each of the countries. All right, submitted proposal documents is just a no-brainer. Whatever you submitted for the grant, make sure you have a copy that's archived and everybody has access to it so you remember what you were gonna do. And then the code of conduct. Allison's walked you through what the elements of that are. There's a number of codes of conduct that are out there. We highlight it here because when you bring in a new tool like a data and digital output management plan, you're adding in some extra responsibilities and agreements from your team that working openly will be how you do it, and you will use common software, common tools, common resources. So many projects will come together, and those teams are coming from different experiences. And if you tell a team who's quite close-knit to work with another team who's quite close-knit, and one likes one tool and one likes another tool, you somehow have to come to a place where sharing is easier and you can all work together in the same area, same tool, same resource. This takes time, it takes training, it takes encouragement, and it takes patience. And this is where a code of conduct can help, where you're asking people to be flexible and potentially learn a new tool, another to do a new thing with a larger international group. Okay, let's move on. So I've highlighted a little bit about these next slides, but I'll just identify this one. So the purpose and criteria for why you do preservation. You want to document and preserve your work. You want to make it easy to use with the good documentation. Don't do this at the end of the project. My God, please don't do that. Do it as you go, because that way it's actually going to be higher quality and more understandable and easier to use by other people. This is a no-brainer, but we're terrible. We're terrible as humans. We wait till the very end. Force yourself. Make yourself do a good job documenting as you go. Give yourself milestones and due dates so that you and your team can do this, and make sure everybody jumps in and it's valued, and you tell people this is important. And then you highlight when you're actually using somebody's documentation, because you say, look, you've made it easy for me. This is why it's working so well today. The documentation you did 6 months ago. Thank you very much. And it's also good for collaboration and protection. All right, so when should you preserve? When is a good time? So I have a question a little bit later in the slides on this, but doing annual reports, for instance, it's good to preserve then. I'll leave it there and we'll talk more about it in a moment. What should you preserve? It's actually not straightforward. So for instance, depending on why and the type of research you have, if you've got research with very large files, you literally cannot do a static backup very often or at all with extremely large files, petabyte, etc. You are going to have to make a decision on what you can preserve and what you can't. So I'm just giving you some ideas here. A full backup, let's say the files are reasonably sized. I would do a yearly static backup associated with your yearly report, do the whole kit and caboodle, but that doesn't mean that you don't have system protection every single day. Like if your laptop fails, your IT team, whoever's supporting you, needs to be able to restore it. This is not in lieu of that. That, I'm assuming, you need to make sure you have that. And I believe Allison's covered that previously. And if she hasn't, let me double down. You must do that. This is project level backup, that you have a copy of everything to put a milestone down. This is where we are with the research today. And it's a static copy and it gets archived and preserved. This is the 1-year work and it's preserved. Okay. And it's for internal use, right? That's what this is. It's for internal use. Now, you might want to do reproducibility, and this could be associated with a peer-reviewed publication and a particular version of what you're doing, and you want to be able to reproduce it. So let's say you have some interim findings or final findings, and you want to be as reproducible as possible. In that case, it's the specific version of everything that went into those research findings. It's not going to be your whole project. It will be certain things within your project. So you have to figure out what those are and what it means to reproduce based on the information that you have, the data, the software, the exact workflow that you used, the method, all of the things that you capture, and making sure you have everything there. It's a high bar, actually. Reproducibility is quite a high bar in order to achieve. And then research integrity. This is like a general concept. What does it mean to actually, let's say in my mind, reproducibility is one thing. It's a very specific finding and I want to be reproducible. Research integrity to me is a little bit more broad. I want to be able to demonstrate for the entire workflow that we've done as a team that our findings have iterated and improved as we've worked as a team. And so you're saving that entire workflow. So it's broader than just a single finding reproducibility, but it's still not everything. So there might be other ways that your team wants to approach a backup, but those are 3 different ways that you can consider and whatever else your team is looking at for preservation. The QR code at the bottom is for a checklist that has all of the preservation information in it that we're covering in these slides, and it's a good material to take a look at and use as a checklist. The content should be quite similar to what you're seeing in these slides. So what are the strategies? All right. So when you're looking at particular research objects and you want them to be fully documented, the approach to them is different, of course. So data is documented differently than software, that's differently than images, and what's preserved. So we're going to talk about each of these in a separate slide. So I'm going to keep moving. Here's data sets. So the metadata and documentation for a data set can be very specific to that type of data. I'm not going to try to explain that here. That's actually probably its own work, course all on its own. But you want to make sure that anything that was created for the project or derived from another data set. So sometimes that's an aggregated data set, sometimes it's some sort of summary data set, or you're combining them. These all should be documented. Did they come from something else? What's the provenance? The original source? And it's important, this note here is worthy of mentioning. For peer-reviewed publications, the publisher commonly asks for the data that supports those findings. It is unlikely that that is all of the data for your research. Your research is probably more than just the data set for that particular research finding. So it is a good idea to think about that when you preserve something for a peer-reviewed publication, it will probably be just a piece of what you do. And you also need to consider preserving the entire data set for your research. You don't have to make that open to the public, but you should preserve it in order to make sure it's well documented and there for use in the future. Let's see, let's keep going. So sometimes we have to reorganize and make sure things are cleaned up and that our headers make sense and they align with proper vocabulary. Machine readability for your data set's important. I'll give you one example that's a gotcha for people who like to use spreadsheets. How many times have you used a spreadsheet and you color-coded certain boxes in order to visualize the difference between certain cells and certain other cells within the spreadsheet? This is no good for machine readability. This is actually horrible. You don't want to do that. You want to actually have a field in there that you can use in, software logic or any other machine action in order to decipher what those color codings were meant. And the other thing that's really horrible for machine readability is when you merge cells. In a spreadsheet, do not merge cells. That is not good. It might look pretty for a pretty report, but when you're trying to use it in a scientific venture, merging cells is not helpful for machine readability. You also don't want to use proprietary software. So think the difference between an Excel spreadsheet and a CSV file. You want to try to be as generic as possible. But because Excel is so widely used, it's hard to get too angry. It's just a little frustrating. If you can use a general format, please do. It makes it easier for everybody else. And then we've talked about the digital object registries and tracking each of the different types. And here we're mentioning it again. Let's see. There is, if you're curious about data documentation and citation, there's a checklist that we've prepared to help you understand what it means to cite data and document it and give you more information. And that's in the QR code right there. It's really helpful, actually. Let's move on to software. So we also have a checklist for software. That's in the bottom right. Software has different challenges. So we're going to assume for this particular discussion that you're likely using a development platform, and it's likely GitHub. GitHub is so popular, or GitLab, or some sort of similar platform. And that's it's a version control platform. We love that very much. As a matter of fact, one of the reasons why we like it. And it's important to document using is it here? There's a new CFF format, code meta.cff that actually helps you to document exactly what's necessary. And then there's also let's see, information about preserving the exact version that you're using for your research. So when you want to actually make the preservation of a particular version, there's a neat little connection between GitHub and Zenodo. I call it the Zenodo bridge. But if you hop on to the instructions, which are down there at the bottom, docs.github.com. I'll let you navigate that URL right there. It walks you through exactly how to do it. So here's the gotcha. Before you preserve on the Zenodo side, make sure your authors are correct, because you don't want the monikers from GitHub. You actually want actual author names, and make sure the ORCID IDs for each of those authors are there and the title makes sense. Those are the gotchas on the metadata when you use the bridge from GitHub to Zenodo. Just double check everything and make sure it's correct. And remember, you can still edit metadata in Zenodo and make it correct and get everybody's attribution. All right, let's keep going. So this is a great example. This is one of the papers that was published with our Belmont Forum grant, and it shows you, if you hop over here to this particular paper, we had to it was about software. So the journal itself wanted exact description of everything from the current code version, the persistent identifier, the permanent link. They wanted to know what the licensing was for that code, and code is different than data. Data is Creative Commons. That's one of the recommended licensing methods to use, and software is different. MIT is one of those. There's also a GNU license. And if you use that QR code from the previous slide, it walks you through what the recommendations for licensing is. So this is an example of what it would look like to document minimally your software. Additional documentation, you could talk about actually have documentation within your software describing how it's used. All right, let's keep moving. So there's other types of digital objects, images and video, also conferences, training, reports, and other materials. And there are many reasons why we would want to capture all of that and share with our funder that we're actually making progress through all of these different types of materials. So they should, in fact, get a digital object identifier. These sorts of items, in images, you might be able to find, depending on your discipline, an actual discipline repository for images, but very commonly you'll end up in a generalist repository. So that QR code for generalist repositories would be here. For our project, we used Zenodo because it's really easy to use, and their terms and conditions are very reasonable. They're a not-for-profit. They're not owned commercially, and their funding is very secure, out of Switzerland with CERN. So it's very scientifically oriented. And so you can also set up a community where your project can identify all of its objects that you're preserving. So, and again, you would want to track all of these in your digital object registry. So, all right. So we're coming back to making sure that you're tracking. This is a little bit duplicative of what we've said earlier and the description I gave on the visualization of where your digital object registry is with your project data, with all of, the umbrella full project. Having information, when you do preserve something, you want to make sure that you have that citation in your registry so you're able to track them back and forth. And here are some of the other, the URL, the DOI URL is very helpful, the date that it was preserved, and a little bit of a description so you know exactly what you're looking for. So Module 3 has more about it within the track sheets. And don't forget that digital object registry, the track sheets themselves, and everything that you're keeping within the registry, those are also digital objects. So save those too, all right? Make sure they're preserved. It's kind of like a meta idea there. So, and the track sheets, this QR code points you to examples of what those track sheets look like that are part of the digital object registry. Alrighty, so I want you to put take a moment, take a deep breath, take a deep breath. That was a lot of information. So you're going to create a timeline for your team of how do you make sure that they're continuing to keep all of those digital objects well documented, identified within those track sheets that are part of your digital object registry. They're preserved at the right time. They're backed up at the right time. They're preserved at the right time. Those are two different times. So when is a good moment in time to rally everybody together and say, all right, don't forget, we have to make sure all this stuff is documented the way we said we would. When would that be? So you can pause the video here. I'm going to keep going. So here we are. So these are very logical times within a grant. So the yearly report I mentioned to you earlier is my go-to. Before and after significant research decisions, our project actually had a bit of a pivot moment where we were thinking one way and then went another. by capturing the original thinking in any of the data sets that we had reviewed. Should we pivoted back, we would have actually made sure we had that well documented at the time. We did not pivot back, but we could have. So that would have been helpful. Prior to public dissemination, before something is published, or even with a poster or an oral presentation, sometimes it's important to get things preserved. Publication of research findings. This is your peer-reviewed publication, the most common moment in time. And then, of course, at the very end of the project, and we have a section in these slides on that. Let's keep going. Data security and intellectual property. I'm going to do a light touch here. Your research office at your institution, you want to make sure you tap into exactly what they're recommending for your country, for your institution, for your country, and then make sure you're comparing across your team. Now, that being said, when you're making choices on the tools you're using for data storage, for software, I want you to pay attention to what the actual terms and conditions are and protections that each of the tools are providing to you. So, for example, and this is a limited example. We could certainly go into this much more in depth, but for GitHub, the terms and conditions are such that it's actually, they're not considered a preservation repository. They're a great development platform, but they're not a preservation repository because it's possible to delete content without the author's permission. So we don't call them a repository, but they do have an advanced security framework to protect content. There are loopholes with that, but there's going to be loopholes with pretty much anything that you're looking at. You just have to know what they are and make sure that when you assign the different roles within GitHub on who has permissions to do what, that you absolutely give the most permissions to those people who are fully trusted, understand how to manage GitHub, and are expected to communicate any significant changes. I had a situation where somebody had actually deleted an entire project's worth of content. And it was a community developed project. And it ended up being an IT person who, because the funding was complete, thought they should shut down the content. And absolutely not. It was community developed. The community continued to use it, and we had to reinstate it. It was incredibly difficult to figure that out. And so I warn you when you're setting up your GitHub to make sure you have all of these things in place. Okay. Zenodo, their default license is CC by 4.0, which requires attribution, and this is an international license. It doesn't work well with software though. CC BY remembers for data. So if you're preserving software in Zenodo, take the time to go through their policies for software and make sure you get that correct. Other text digital objects, it's fine. And then one of the discipline-specific data repositories that the team that developed all this guidance used was Environmental Data Initiative, EDI. EDI is Core Trust Seal certified, and it means that they consider how to handle, should they go under and not be able to support the data any longer, if their funding runs out and their ability to have an infrastructure is no longer possible, they actually have what they call a cold dark archive, a cold data archive, in order to ensure their data is available and can be hosted elsewhere. This matters. It matters that you think this through. The good news is, once you think it through for the first time, you can use those resources again, and it's a lot less burden on your brain. So take some time once to get it correct, and then you can use these resources again and recommend them to others. All right. So something also, when you're talking about intellectual property rights and you're talking about attribution, how you're going to determine attribution, I want you to consider documenting all of that very clearly in your code of conduct. You don't want to be having an argument at the time you're publishing or registering your intellectual property, that's too late. It's too late, and probably somebody's feeling left out and not included when they had made a contribution. Figure it out ahead of time. Make sure that the method you're going to use is documented and compliant with all institutions involved, all country laws involved, and get the signature on that code of conduct. It's not a legal signature, but it is an agreement to follow this practice. And a signature is meaningful to each of your research members. It will really help solve attribution issues, contribution issues, and intellectual property issues later. All right. And the DDOMP that we used for Parsec, which has our documentation in it, is available at that QR code. So here's something. Along those lines, is there anything in addition to ensure proper attribution for each of the outputs that have created from your project, no matter what type of digital output it is? What sort of thing should you be thinking about to ensure that that's true and happens? So let's say it's a new model that you've created from your grant, and you've preserved it. You built it in GitHub, you preserved it in Zenodo. It's now cited in a peer-reviewed publication. What can you do to make sure that if somebody else uses that model, that the creators of the model will get credit and attribution? I don't have a slide that follows this that actually gives you some answers, but one way to do it is to actually write the recommended citation as part of a README or very close to where you're describing the object so that people know what to do. And then track the usage, and if somebody gets it wrong, ask them to correct it so that you have the digital connection between the persistent identifier for your object and anybody else's paper, and it's accurate and it's easy to count, and the citations eventually will count, and someday everybody's promotion and tenure will actually include citations for the digital objects they create other than for peer-reviewed publication. That's important. Let's keep going. So costs. All right, this is really interesting. Many of our funders out there, especially national funders, will include data management costs within the budget. Belmont Forum recommends it, but they depend on each of the country funders in order to implement it. So here's your slide to give you an idea of what to think about. And this is hard to actually get accurate until you've gotten into the project. So do your best effort. Some estimates are data management is going to be 5% of the project. Some of the higher estimates I've seen are 10% of the project. Now, it depends on what you're counting. When we did this for our project, the time for curation, we just included in the existing time that was being either volunteered or the postdoc time. So we didn't have additional costs here. We weren't putting the burden on some new person that we were going to pay as a consultant or technician or something. So the time to prepare metadata, here in the number 3, the time to do quality checks, the time to prepare metadata, we didn't really have a cost for that. It was embedded in the people that were already being included. One thing that might have cost us money was we wanted to purchase satellite imagery. We found a free source out of the United States. So it is a good idea to check with all of the teammates to see if their satellite or their data sources are free within their country. And then you can actually provide that to your team. Or I know that, for instance, some agreements for proprietary data can be made by a particular institution, and you may just have to partner with that institution to get free access to that proprietary data. You have to be a little savvy there because those aren't usually published. Those agreements are not usually published. You have to usually ask around for that. In the end, we actually didn't have any data management costs. We used repositories that were all free. Some repositories are not. Some cost money for curation. We did have costs for publication, and publication is listed here because in open science, open access is included, and some publishers require that your peer-reviewed publications be in an open access journal. At this moment in time, there are some free journals, some diamond journals that are free. That's a type of journal that has free a publication. But a lot of our researchers prefer some of the journals that are more well-known and recognized within their community, and those have APC fees, so costs for publication, and they tend to have extra fees for open access because the funding model for a publisher in open access is at the moment in time that the author publishes. There's no additional revenue that the publisher gets. Someday this will get better, but today there's extra fees for open access. Do plan for that. So it's not data management, but it is open access fees, and do make sure that you're planning for exactly what those costs will be. All right, so where would you look to estimate costs? I've given you a lot of hints, so hopefully I've helped out there. And it's kind of fun to think about what you think a reasonable cost might be. When you realize somebody's going to use your data or use your software, and you're like, woo, I'm not familiar with how to make it ready for somebody else to use. It kind of is a good exercise to think through what it would mean to actually do a good job. And it's also good to ask around and get help. There are resources available, certainly within the work that I do, but ask Belmont and see what resources they have available. So let's talk about the end of the project. Here we are. We've made it. Congratulations, you've published. It's time to do a full backup and close out. So I want to remind you of all of the things we've talked about. There are shared working spaces that don't normally get picked up. Like, unless you've put in a backup for your Google Drive, if you use Google Drive, you have to make sure you grab that. A project website. Project websites are notorious. They very commonly are not maintained after the funding's run out from the grant. Those websites keel over and die. They are incredibly valuable for the materials that are made available to everyone, and sometimes are still needed, especially when you're closing out the last bits of papers that you're writing. You want to make sure you have access to these shared spaces. So think about what that means. It's really important. It's a little bit more beyond what I had in the research project. We had all the interim files, we had the digital object registry, and these are all of these serendipitous shared spaces that are just pretty quick places to work, plus a website. So it's important that these things also get preserved. So there's your pro tip for the moment. And that ends preservation. So we talked about it in multiple places. This is your final slide. This is your final slide for Module 4. It's your final slide for the 4 modules altogether. And I want you to pay attention to this. These are, there's a paper about how we wrote the data and digital object management workbook. In that paper, Allison led that project, and that QR code is right there. And in the paper, you're going to find these top tips. And I want you to note that they're all people-oriented. Doing something new, maintaining documentation, and ensuring everybody's all on the same page and with the same goals and working together in collaboration for effective and exciting, innovative opportunity really means that people need to work together and trust each other. That time that you take to make those connections, relationships, and build those friendships is going to be the reason your research is amazing, because you'll be excited to call your colleague. You'll be excited to reach out to the team in Asia. You'll be excited to reach out to the team in South America, because the work that they're doing is going to be so monumental for whatever, ... I am so proud of the work that we've done with our Belmont Forum team, and I'm really hoping that you have the same incredible experience. And this is one of the ways that that happens. So make sure everybody's committed to the same goals. Make sure that when you bring someone on, you talk to them about what it means to share their objects, that how you use common spaces, and this is how you create a highly effective team. Make sure they understand. You don't want someone to come onto your team who won't do that. That's not helpful. This is an opportunity to change hearts and minds. So help them see why it's important. And provide a way for your team members to tell you when something's not working. Sometimes a tool is going to be hard to use and it's not going to go well, and you're going to need another way around a problem. Make sure that you're there to listen and try to solve those problems. It's worth figuring it out. And as long as everybody's working to the same goals, the problems will be solved. You'll figure it out. Um, Not everyone's going to know how to use all this stuff. Not everyone's going to know why it's important. They won't see the point. I don't get credit for a data set. I'm not going to take the time to document it. All right, fine. You don't get credit for it, but in 5 years, you're going to want to use it, and your memory's not that good. You need to frankly write stuff down. So let's just go to some basics. If you want to document it for yourself, you're going to have to write stuff down. Just do it, right? Just help them understand. And then make it easy on people. Create a reference for all the resources, shortcuts, folders. There's a lot of content here. Make it easy for people to find it and use it. You can be creative. Some of these things can be really fun. All right. Well, thank you. Thank you everyone for taking the time to go through this, to spend time with Allison and I. I hope you found this to be incredibly valuable. This is your legacy. By implementing these types of management plans and workbooks, figuring out your digital objects, this is what fuels your research. This is what makes you able to have that incredible, innovative moment and incredible opportunity that will not only be rich for your current team, but the next teams. And I'm really excited for what's going to be possible. And I can't wait if we ever run into each other at some meeting. I want to know. I want to know how it went. And when we talk about attribution and tracking everyone who's involved, our one project included all of these partners. And they came and went, or they stayed the entire time. They were all critical and wonderful and helped us to do our best possible work. We are incredibly grateful to all of them. And we use slides like this to make sure we don't forget anybody. And thank you to you all, and have a wonderful project.